Right, this is going to be lesson 2.4 for Math 1. And we're going to go and start with a couple of warm-up problems. So go and work 1 and 2. This is evaluating expressions for number 1. Here you're going to solve. So this is your flipping, combining, and dividing. And then I want you to take a look at number 3 and just kind of think about the problem and write down what your initial thoughts are about it. Specifically looking at this question, does doubling your speed double your stopping distance? And then go ahead and stop here. Table A, this is the beginning of the lesson, so don't go on to that. And then unpause when you're ready to see the results. Okay, so hopefully you've gotten the equations or the warm-up done. We're going to go and work through these. So as we look through this order of operations, nothing to do in the parentheses, but there is an exponent. Remember, when you see negative 3 squared, that is negative 3 times negative 3. And a negative times a negative is a positive because negatives cancel in pairs. So that negative 3 squared becomes 9. Then we'll come to our next step, which is going to be multiplication. The 2 times 9, which is 18. This minus sign is still there. And then 5 minus 18 is going to give you a 13. Just a reminder, whenever you do these kind of problems, run them through a calculator. Make sure that that answer comes out correct. Oh, negative. It's a war. Negatives win, so negative 13 is your answer. For this problem here, we're going to be solving equations. And you may have not seen one like this before. It has a negative in front of the 3x. And the lesson that we did earlier in this chapter, I didn't throw any negatives, I don't believe, in front of the x term. The processes are still the same, though. First, we're going to flip. Remember, our goal is to have x terms on one side, number terms on the other. This 5, we want this on the opposite side, away from the x. So the 23 and the 5 will be on the same side. So 23 stays here. I flip the 5 over, and it's a positive 5, so it becomes a negative 5. There is still this minus here, which goes to the 3x, and it does not go away. When you flip the 5, it's positive because there's no sign in front of it, which means it's positive, right? If it's negative, we put a negative. If it's positive and there's nothing else in front of it, I don't need a plus sign for it, so we just assume it's positive. But when we flip it, it becomes negative. Let's go ahead and do our combining over here. This is a war. 18 is left over because positives win. And we still have negative 3x on this side. Our last step is dividing, and we divide by whatever's in front of the x. In this case, it's a negative 3, so we're going to divide both sides by a negative 3. So the thing I want you to kind of catch from this is whatever's in front of x is what you're going to divide by. If it's a negative number, then you're going to divide both sides by a negative number. All right, that will leave you with just an x over here, and 18 divided by negative 3 is negative 6. Is our answer correct? Remember, we can always run these through our calculator. So I'm going to pull a calculator up here. And so I'm going to do 5 minus 3, and then we said negative 6 is our answer. So I'm going to put a negative 6 in parentheses, and I get a 23, which confirms the value on the right side. While we're here, might as well just run this through. 5 minus 2, parenthesis, negative 3 squared. That's the problem that we had in number 1. And negative 13 is confirmed. All right. Considering the distance it takes to stop a car. Your speed is the main factor in how much distance it takes to stop. Does doubling your speed double your stopping distance? And so it's kind of an interesting question. There are things that when you double one value, it doubles the other. Here's an example. If you're getting gas at the gas station, and you put in 4 gallons and it costs a certain amount. If you decide to put in 8 gallons, if you go from 4 gallons of gas to 8 gallons, your cost does double. How much you're going to pay. And so there are definitely situations that work that way. But there are other situations that don't. And this stopping distance actually doesn't work that way. If you double your speed, it takes more than double the distance to stop. And so there's not like a formula or anything that I have to give you this or to explain why. This is just data that they've taken. So they take cars and they drive them at a certain speed, they slam on the brakes, they measure the skid marks. And then they double the speed and they measure those skid marks. And they're definitely longer than twice as much. So in this case, no, it takes more than double the distance. So like I said, some things do have this relationship that if you double one thing, the other thing doubles, like double the amount of gas, it doubles the cost, but there are things that do not. We're going to take a look at some data at the end of this lesson and take a look at the graph. But I want to do some other graphs first, and then we'll kind of compare them. So what I want to do here is we're going to just plot points in a table. In our earlier lesson in this chapter, we practiced plotting points, and we're going to do the same thing here. Let me go move this out a little bit. There we go. All right, I think that looks pretty good. So here we're going to go ahead and graph. So -2, -3. Remember, this is left and right. The y values are up and down. If it's positive, you go to the right. If it's negative, you go left. With the y values, if it's positive, you go up. If it's negative, you go down. So in this case, they're both negative. So this is going to be left 2 and down 3 from the origin, from 0, 0. So let's go left 2, 1, 2, and down 3, 1, 2, 3. If you look at the point, if I look up, -2 is the x value. And if I look across, -3 is the y value. Next one, -1, -1. That's one left and one down. Go ahead and finish the rest of the points. And then once you're you might want to pause and just wait till you finish and then unpause. Okay, if you have the points graphed, I'll go ahead and finish them off. So 0, 1, this one gets people sometimes because they want to like move right away. But this says to move 0 left and right. So you're not going to move left, you're not going to move right. You're going to be along this y-axis. And it has a 1, so you're just going to move 1 unit up, and that's it. And it puts you in this location. Now 1, 3, that's 1 to the right, 3 up. And 2, 5 is 2 to the right, 5 up. And so we can see these points here. I'm going to go ahead and connect the dots on these. I'm just going to draw a nice straight line here. This graph is a line. And so for table A, I'm going to write down the word line. Then I'm going to add an AR to it. And that's linear. So this is a linear equation. We'll say a linear, do I want to use the word equation? We'll just write linear. So this is linear, meaning the points line up in a line. And there is a rule for this. I'm going to go ahead and give you that rule. It is 2x plus 1. So in other words, if I take one of these y values and I multiply it by 2 and I add 1, I think I said that wrong. Let me back up. If you take one of these x values, multiply it by 2 and add 1, it will give you the y value. For example, let's take the -2. So I'm going to do y equals, we'll say if x equals -2 on the table, we should get -3 when I plug it in. So we get y equals 2 times -3 plus 1. So where the x was, I put -2. Gosh dang it. I apologize. I plugged in the wrong number. -2. So I plug in the x value where the x was. Whenever you plug something in, put parentheses around it. This will remind you that this is 2 times the value. And so you're going to get 2 times -2 Multiply that, that's 4, and it's going to be negative because there's only one negative there, nothing to cancel it. And negative 4 plus 1, that is a war. Negatives win. So you get negative 3, which is what we said the y value would be. What if we did, let's say, positive 1? So we'll just do another one. What if x equals 1? So we would put in 2, and in place of x, we're going to put 1 plus 1. 2 times 1 is 2, and 2 plus 1 is 3. And that is the value that we got in our table. So this line is actually all the points that if you plug in different x values, the y values show up. And so we could even go, like if I plugged in 4, if I go all the way up here, I'm seeing that's 9. So if I plug 4 into that equation, I will get 9. And we'll just do that as kind of our last example here. So if I go if, and I know it wasn't on our table, but we can pull it from the graph too. If x equals 4, then we get y equals 2 times, and in place of x we put 4 plus 1. 2 times 4 is 8. 8 plus 1 is 9. So if x is 4, y is 9, and indeed we see if we go up to the table at 4, the y value is 9. The important thing about the equations is, well, what if I wanted to know the y value when x is 20? Well, my graph doesn't go to 20, so I can't extend out to that unless I try to make a bigger graph. That sounds like a lot of work. 20 is not on my table. Now I could continue the table down, right? Here you can see that the values are increasing by 2 each time. So I guess you could just continue the table down till you got to 20. But once again, that seems like a lot of work. Well, if I wanted to find the value when x equals 20, I could just put, if x equals 20, then we have y equals 2 times 20 plus 1. So in place of the x, I put 20. 2 times 20 is 40. 40 plus 1 is 41. And now the equation allows me to find values that are far away from the graph and further down the table immediately. So I don't have to do a lot of work to get there by expanding the table or trying to graph it all the way up to that, up to that value. We can just use the equation to plug it in. All right, let's go to our next problem. I want to point out the goal for this lesson is mostly graphing points. I want to make sure that we're looking at graphs, but I also want to show you what different types of graphs look like. I'm not going to ask you to tell me what type of graph it is or stuff like that. That'll be a later class. For right now, we're just focusing on graphing the points. For this one here, we have a set of points. Go ahead and pause, graph those points, and then unpause, and we'll check to see how you did. Okay, hopefully you have those points graphed. We're going to start with negative 2, 4. So negative 2 means 2 to the left, and then 4 is 4 up. Our next point, 1 to the left and 1 up. Our next point, 0 to the left and 0 up. That leaves us right here at 0, 0. We call that point the origin. Then 1, 1 is 1 right and 1 up. And next one's 2 right and 4 up. And this, do not connect the dots with straight lines. This is actually a curved graph. So it looks kind of like this. And I'm going to go ahead and give you the rule for it. It is y equals x squared. So y equals x squared, all I do is plug in the x value, square it, and I get the y. So if I did, if x equals 2, that means I get 2 squared, which is 4. So we can see that rule right there. If I put if x equals negative 2, negative 2 squared is also 4, because negative 2 squared is negative 2 times negative 2. Two negatives, they make a positive. All right. I do want to add one more point here, and that point is when x equals 3. So we'll have y equals, and then we'll put 3 squared, which is 9. and if x equals -3. Well, if you do -3 squared, it's still +9. So we're going to add these 2 points to it. I'm just going to do that because it kind of completes the graph here. We've got this empty space here, and this graph actually continues to grow, so we can extend these lines this way. And you'll notice that there are no negative values, right? All of the points are here where y is positive. There are no parts of the graph that are down here, because when you square a number, you get a positive. Doesn't matter whether it's positive or negative. If you square a negative, it's a negative times a negative, which still is a positive. So there are no negative values here. This graph that has this kind of U shape to it, this is called a quadratic, or a parabola. All right. Once again, I'm not requiring you to memorize that. I'm just showing you different types of graphs that you might see. All right. I think, how many problems do I have left? Yeah, I think I'm going to go ahead and pause this because we're about 15 minutes in, a little bit over, and so I'm going to stop the video here, and please continue on to part 2.